Hello everybody. I hope you had a nice lunch. I hope you don't fall asleep. Lunch, is or the session after lunch is the hardest. I hope you took the liberty to get some fresh air. And so you're ready here. I have to apologize, I can't see anything. I'm blinded. There's a big beam going right into my eye. So if I try to do eye contact, like a silhouette. And anyway, I'll try my best. Okay, so the presentation I'm going to have today is about the buzzword open or the prefix open and the benefits that has for network operators. So as you obviously probably know, there's like so many out there. I don't even want to suggest that I will cover all of those, but at least I try to cover some that are more prominent and also where I think we as Brocade have some very meaningful input and some meaningful messaging around it. So let me move forward with a little bit of history, or let's just say, the evolution of networks. So it all began with a mainframe where you had a couple of nodes, a couple of users, and a couple of applications, be it hundreds, maybe thousands, but at least it was like a number that was pretty confined. Later, what is often referred to as the second platform, which is the client-server-based architectures we were having millions of devices, and whatever the number is, millions of applications running on top of that infrastructure. And the internet as such was good enough to carry that, and this is literally what we're using right now. But you all also are aware that there's a huge transition right now, basically led by a couple of trends, mega trends, being social networking, cloud computing, the rise of the mobile networks, and also big data crunching that is happening every day. And if you look at those number of devices or that scale, everyone agrees. In particular, 87% of the CIOs, according to Gartner, that you can't scale to that with the current architecture. Right, so this is not like a statement of mine, but it's really like a industry consensus that the networks have to change in order to accommodate for those trends. And if you don't, your network typically doesn't perform well, your application doesn't run well, and it's not well accepted. So what does it mean, right? So or what components do you have in those data center architectures or in those networking architectures? And I just wanted to bring up here the components we're having. So obviously you need storage, and you need to connect your storage to your servers. So you can do all the big data crunching. You need spanning trees over, right? I mean, it should have lived for 6 months. It lived way longer, but no one wants to build networks using spanning tree anymore. So you need something more elastic, more scalable, and easier to handle. So you need fabrics rather than classic networks. You still need extensive routing capabilities into those mega data centers. But on the other hand, also you need to have all of that very well controlled. So you can't do CLI anymore. It just doesn't scale. As I said, it needs to be, your app needs to tell the network what it needs, and then the network needs to essentially auto-provision to make sure that the resources that are required are available. Another trend here that basically goes hand in hand is network functions virtualization. So when you were using appliances earlier, I mean, you could possibly handle 10, 100, 1,000 hardware appliances. But if you need 10,000 appliances such as Amazon Web Services or Rackspace, and if you have whatever the number is of residential customers or small customers using your services, then obviously you need to spin up your services really fast and really agile without any human touching the process. And this is where you need network functions virtualization, right? And obviously, your whole cloud needs to be orchestrated. I mean, here in this slide, we have the little pane of glass, the iPad, where you touch it and then you control your whole network. You know, eventually we will be there. It takes a little longer, but eventually we will be there. So let me go to what I refer to as the OC stack of data centers. I mean, you all know the OC stack, layer 2, layer 3, IP, TCP, UDP, and so on and so forth. It has a model. It's a model that served us well for the last 2 decades. But I think there's another model that's actually more relevant. So the first one is, obviously, in your infrastructure, you need to have a physical underlay, right? And like I mentioned earlier, in the storage, this is fiber channel in the most critical applications, but also other storage trends are emerging. You need a compute infrastructure, and you need a network infrastructure where Ethernet fabrics are becoming the de facto standard. And wherever I have a little extra icon on there, this is where we, as Brocade, are actually invested, and where we are contributing solutions or effort to this layer of the stack, if you want, right? So the next layer is the virtual infrastructure. So obviously, you have virtualization technologies for the network, such as VXLAN, NVGRE, virtual fabrics, or VPLS, or whatever, even vSwitch from the network virtualization vendors. You have, like I said earlier, NFV, basically a router that becomes a virtual appliance on top of your elastic data center infrastructure. You have virtualized storage, and you have virtualized servers using KVM as the open trend, just to name one open representative of this. And this is where probably you, being in the service provider market, see the biggest interest. So when we look around, it's most of the times it's VMware competing with KVM, right? And it depends mostly on whether operators want to use a packaged solution or they want to be completely open, in which case they go for KVM and the ecosphere around it, like libvirt and OpenVSwitch and so on and so forth. So moving forward, obviously you need some way to control the whole infrastructure, which is why we have decided to embrace OpenDaylight. You see the logo here, and basically have a controller that sits between your applications and your network to orchestrate or to translate the orchestration, your business demands, to network configuration. And one other open here is actually, you see the Openflow logo here, and I'll come to that a little later. And then last but not least, on top are your network applications or your business logic, whatever your provisioning model means. And all of that needs to be controlled by something that will probably become OpenStack eventually, right? So let's move forward. Let's begin with the first open, which I happened to pick Openflow for. So let's see where Openflow is today, right? So obviously, what Openflow does, I'm not sure whether you had spent time on it, so let me, in a minute, in a nutshell, I'll recap it. So basically, typically a router has a brain and does BGP calculation or MPLS or whatever. And now, with Openflow, what you do is you have some off-box computation of your forwarding rules. Then you use a standardized protocol such as Openflow to actually push flow rules into your device. Now, unfortunately, the way this is often done is that people turn off the brain of the switch completely, and it just becomes a dumb Openflow switch, right? And we haven't seen that many networks that are built from the ground up, so it's not really too much of a useful approach. More often, what you have is you have already an installed base, and you want to add services on top of this, which is where our well, we baptized it, the hybrid port mode comes into play, which is basically a traditional control plane running on your devices, which deals with whatever 80, 90% of the traffic you have, and only those special 10% extra of, let's say, requirements you cannot easily fulfill with your MPLS or IP control plane. You add the SDN controller on top, and basically you interleave your Openflow rules with your traditional control plane. You can, or cannot, depending on your choice, run a protection layer between those two, and make sure that your Openflow rules do not interfere at all with your traditional networking rules, or you can go the next step and completely interleave the two. So if you use the Openflow jargon for that, it's basically the normal mode, or the normal forwarding, the fallback to normal forwarding in Openflow that we can do on all the ports in the device, and that is needed. So having talked about Openflow, I'm not sure you're aware, maybe you have the term before, I'm not sure how much you invested in this, but it's pretty much like BGP, right? Everyone can claim he does BGP, but BGP consists of so many different features and functionalities that in order to judge whether an implementation is ready to support your requirements, you really need to look at all the aspects of it and all the details of that in order to make sure that you have something that works. And the same holds true for Openflow. So if you just look at, that is high level, right? So the Openflow spec is much wider, and it's just, basically has this big title, Openflow 1.3, right? But just looking at a couple of high-level things here, you'll see what sub-features have been introduced in Openflow 1.3, which is what the industry is currently developing towards, right? And where it says yes, or yes with an asterisk, this is where we have, support that functionality. So, and it's actually relevant for the next slide I'm having. So this is why I'm wanted to show this to you, right? So as you can see, obviously port match is a very trivial one, which was supported in 1.0 as well. But then there might be more complex things, such as you match a packet, you meter it, which is the per flow meters towards your right, and then if you dropped a couple of packets to comply with your policy, then whatever is left, you forward, or you expose to your normal forwarding rules for let's say final forwarding out the node. Right, and look at, it takes a minute or so, and look at the other things that are really relevant. IPv6, MPLS support, and so on and so forth. So, Openflow is just, a nice set of standards, and there are plug fests every now and then, and many vendors claim support for this. But what can you, as an operator, really do with that? And we are fortunate enough to have a couple of customers that actually have Openflow in production, and I want to quickly introduce to you what they're using to give you some idea about what can be done with that technology. So basically, that example I picked is titled Volumetric Traffic Management, and it can be a DDoS attack. It can be a large, healthy flow that you run through your network that you want to give special treatment for, or something other large volume traffic that needs, doesn't do well when it competes with all the small, short-lived flows, right? So if you use SFlow on the device and send those samples to a collector, external collector, then those large flows can be easily detected by SFlow as being a sampling technique, very let's say sensitive to large flows. Then you can do some analysis of the flow samples, and then you can detect signatures, or let's say, those flows, and then you can use that to extract a set of flow parameters that you want to push into your devices using Openflow. And that can all be done automatically, obviously. And like I said, the benefit could be if you have a large DDoS attack in your network, for example. This is automatically detected by SFlow. The app recognizes the attack and drops that black holes the traffic, or drop some of the traffic, or sends the traffic to a washing machine for off-box treatment, for some kind of, let's say, cleansing appliance or cleansing service that you can buy on the internet. The only point, though, is that if you run each and every part of your traffic through this appliance, it's typically very costly. And here you can easily forward all the traffic by your network, and just the specific rules and the specific flows get a special treatment. You can alleviate a lot of cost from your infrastructure by using that approach. And that actually in use by Indiana University, for example, one of our very early Openflow customers, where they basically bypass the firewall for known and validated flows, or like I said, DDoS in many of the ISP networks. So that's a true benefit, and we're looking for more examples of where this can be used or other approaches, other ideas where customers can benefit from this. So the next section or next flavor of open that I want to talk about is software-defined networking. In our case, using the OpenDaylight controller. So we have made an effort to actually go out and create a distribution for OpenDaylight, which is Brocade branded, much like Red Hat has a Linux distribution and supports it. Brocade has a supported distribution of the OpenDaylight controller and can give you tag support and everything that's needed to make sure that your service is actually up and running. Can give you insurance for your service, right? So let's just see what the use case here is or what you have. So typically, you have in a multi-vendor network, you have your silos of vendors, and they talk OSPF or BGP or whatever other routing protocol to each other, spanning tree if that matters. And typically, you have CLIs or vendor-specific APIs to talk to each of that stack of vendors. And this is, like I said, the way we built out the internet. It scales to a certain point, but clearly it's not ready to support what we discussed earlier, right? Which is why people tend to look at this picture here, where basically you have all the vendors supporting ideally a standardized means of communication. In the best case, it is standardized, such as netconf. The worst case, it's a restconf, and then you have a Yang model describing it. But then you have a controller that basically abstracts those devices' API to your business, or to your northbound API, or to your business logic, to applications. And the application just requests whatever it needs from the controller, and that in turn translates it to whatever is it needs from each of the vendors' let's say devices, right? And ideally, it's normalized across all of those. But even if it's standardized just per vendor, it's a one-time integration effort, and then you can still kind of abstract it for your day-to-day operations. And why is that relevant, right? So basically, it's a pretty simple slide, but I think it's really useful. So right now, if you look at a vendor, even us, you might feel that if you have a specific request for a certain functionality, the only one to deliver this to you is us, because it's our proprietary code, and we are the only ones who are allowed to touch it. And hence, if for whatever reason we are not in a position to give it to you, you might feel like you don't have a leverage, and vendors are on the longer arm of this balance. So the idea is that open systems such as OpenDaylight can change this, and basically you have a community of developers that solves common problems and uses those normalized APIs, and then your business applications are already solved from the community, or in the worst case, you can apply the resources and you can program against those normalized APIs and make that functionality available for you and for your business. So you might now argue, why are we embracing this? The rationale is pretty simple, because we feel that we can substantially benefit from that community basically helping us to provide more and better and more adequate solutions for your typical requirements, much better than we could do on our own. Which is why we want to leverage this force multiplier, if you want, to get services to you, right? So let's see. So what does it mean with regards to the OpenDaylight project? So basically, what we're doing is we take the code, we package it, we give it out. If we fix something, we basically send everything northbound to the open source community project, OpenDaylight. Then next release, we take it back, repackage it, fix it, and then again do northbound. So we want to make sure we're always in sync with the distribution, with the OpenDaylight public distribution, and don't kind of bifurcate away from that. And the things we have contributed up front already, or by now, is we have contributed Openflow 1.0 and 1.3 interfaces, the akka framework, which is basically the high availability clustering solution in OpenDaylight, loads and loads of young models for the devices, some service abstraction layers, and if you want, you can actually go to the URLs that are shown at the bottom here, and go through it, read through it, and spend time digesting, or even start developing or introducing it into your environments. So one of the potential use cases or a higher level architecture picture of that would be that you have the controller in the middle, hydrogen. So OpenDaylight has picked actually I don't know the English term for this, but the periodic system for the chemical elements to infer the names from. So hydrogen was the first release, helium is the second, which is the current basis for our current version. And as you can see here, it sits in the middle, providing control to your network. And it can, for example, communicate to OpenStack in the northbound, but it can also program directly against the APIs, northbound APIs of OpenDaylight, and some of the applications that we have developed, for example, this volumetric traffic management, actually sits at the northbound application on top of the Vayada controller, or the OpenDaylight controller for that matter. But on the southbound, you can also have, besides Openflow, you can also have a netconf-yang-based communication to, for example, a large bunch of virtualized network functions, or even physical appliances. And like I said, the controller can take away the pain of managing each and every individual device individually. So, last flavor of open, if you want, is OpenStack. I actually have seen someone earlier wearing a Mirantis shirt. I'm not sure whether that person is happens to be in this room. So Mirantis is actually a partner. So, are you happy to have you here? So, do you work for Mirantis or? Okay, okay. I didn't know. So I know that over in San Jose, we have a very close relationship because Mirantis is one of the OpenStack distributions, probably the more developed ones. I mean, it's up to you to comment on that if you want later. And we are basically very closely cooperating, and we had your colleagues in our headquarters and telling us about the most recent developments in OpenStack. So obviously, we are not the OpenStack experts, right? We just follow those developments, and then we work with Mirantis, for example, for them to package the OpenStack, and then we basically make sure we check in our plugins and whatnot, right?
Okay, so maybe I will wait for your further presentation. To tell the truth, I'm quite a new person here in Mirantis, Poland. So a lot of information are quite new for me. So probably I do not know a lot about the cooperation between companies like yours. But okay, of course I can share all information I have in that field.
Okay. Yeah.
Thank you.
Let's see. Anyway, I know we are closely entangled here in cooperating around this, which is kind of good. So let's see where we are with OpenStack, right? So obviously, what is OpenStack? For those of you who do not know, it is again open source, right? It's a community effort that has been started by Rackspace and NASA for very interesting reasons. And it's basically there to provide management for your cloud, the storage, the compute, and also the networking piece of your infrastructure. Initially there was some competition there, but now it seems to be emerging as the dominant open source or open community type of solution. There are other closed ones. Obviously, VMware has its own, let's say, solution to manage your data center and your infrastructure in the data center. But OpenStack has the advantage of being open, and you don't have to pay any licenses to any vendor if you want. I'm not sure whether the 200 participants is still correct and the 6,000 developers, but like I said, it's open source and open community, so it can be any number here, probably even larger dark number which of developers that are not even that obvious. And like I said, this is already in use. Rackspace has gone to service very early with that. I think they use like a modified, slightly modified version of OpenStack in order to deliver their cloud services to the industry. So what does it mean? So basically, if you want, so OpenStack basically, like I said, gives you the control over the infrastructure. And if you want your network elements, if you want to be controlled by OpenStack, you actually have to either provide a plugin to OpenStack so it knows what to talk to your devices, or you can go through the controller. Both are possible, and both are actually done or are in use. But they are a little bit different approach in both. And we have contributed in a numerous ways. So our vRouter, Viata vRouter, can be controlled using OpenStack, instantiated and controlled using OpenStack. Our Ethernet fabric can be, there's a plugin available, so it can be controlled through OpenStack. Our virtual load balancer can be managed using OpenStack. I'll talk a little more about what we did with the co-routing and OpenStack. And even for the SAN, storage area networking, we actually have invested in making this accessible to OpenStack, so it can be easily controlled, right? So there are a number of distries out there, Mirantis being one. I'm actually not sure why it's not listed here. Red Hat and Rackspace are others, but Mirantis seems to be the emerging one, so they have picked up a lot of momentum over the last whatever month. So let's see. So OpenStack gets its name from alphabetical numbering. So October 2013, there was a distribution called Havana, and by the time we had managed to provide management for our Ethernet fabric technology. Later in the Icehouse release, we managed to put in support for our load balancing, ADX, and our SAN. And in Juno, we expect to have all of that checked into the distribution, so you don't have to go through a lot of effort and actually introduce that yourself, which is obviously always possible. You can always download a distribution and then basically insert your own plugins into this. It's just a little bit more hassle if you go through a supported distribution. So what did we do with this? At the Open Networking Summit a while back, we actually had provisioned this setup using OpenStack. So we were emulating a 2 data center infrastructure with a wide area network in between, being delivered by 2 redundant nodes of VPLS interconnect in both data centers. Then we had a Ethernet fabric in the aggregation of each data center to actually connect your servers and everything. And when we deployed, the service, so that the virtual machines could seamlessly move between those data centers, we were actually translating this into VPLS commands for the PE routers at the border of those data centers, and to the appropriate VLAN commands in the aggregation networks within the data center. And obviously, if you have hundreds and thousands of interconnections, you can see where the benefit lies here for you. So again, this is available technology, available solutions, nothing out in the blue. It's actually ready to consume if you want. Sorry. Okay, so let me have a quick summary of what we discussed here before we go into some Q&A. So let me go back to this slide deck. I hope that I have given you some insight as to why we think open can help you solve the problems that arise from those megatrends that we had mentioned earlier, that translate into billions of devices connecting and billions of apps using the network each and every day. So what does it mean for you? The benefits that we see for you, tangible ones. So the first remark I have is, remember Linux in the 90s, right? No one was taking Linux serious at the time. Some universities were using it, some geeks back home. Now it's the de facto standard in most production networks. No ISP can run without at least one Linux service in each and every network, if not more. And all the projects, all the trends are available. KVM, everything is available on Linux. The open networking projects that I discussed and many more are still in a rapid development phase. So they are at a varying degree of maturity. That means that some things are already consumable, some are not. Some are still very painful to do, and it's absolutely clear, and I don't want to set the wrong expectations here, that you have to invest yourself, either through development resources or through partners or through us, for example, with regards to the OpenDaylight controller or the Brocade UADA controller, to actually help you through those initial stages. But eventually, over time, the open source community will contribute to this project, and the libraries solutions will become available, and this will be the disruptive standard for the agile and flexible networks that you need to build and you need to run to support your applications, your cloud services. And my appeal to you is not go out and deploy open right now. Maybe that's too soon, but at least define a strategic mindset towards open, so you're not locking yourself into something that you can't change anymore. All the major players are behind this trend, and even if you're not ready yet, in a year's time, or maybe 18 months or 2 years' time from now, I'm sure you will have some component of open somewhere in your network. And this is why I suggest you open your mind and challenge your RFPs if you run through some, or in your conversations with vendors, colleagues, whatever. Explore what open means for them and what it can mean to you. So the last summary slide, or the last slide I'm having, is the level of commitment we have towards the industry. So we have hired a number of Illuminate people that you can see here to help us follow many of the standardization bodies that deal with those projects and standards each and every day. And if you go to these, if you go to IETF, you're very likely to bump into David Meyer or John Hudson very easily. And if you want, you can always kind of talk to them, because they're very accessible and very flexible as well. So with that, I thank you for your time, for your attendance and for your attention. And I see no one fell asleep, which is good. I didn't do too bad, sorry. If you have any questions, I'm more than happy to take some. I have like a couple more minutes for that. If not, Brocade has a booth out there, not too far away. I think like 2-3 booths down the row on the right, just close to the lockpicking, between the lockpicking and this room actually. I won't be there later, I have to leave and catch a flight, but my colleagues at the booth will be more than happy to have conversations with you if you want. So, questions, any?
So thank you for your speech. Big applause.